Hello, it's Christian the CTF noob again, and today we're going to have a look at the 6th behemoth challenge from OverTheWire. And today, for the first time, I'm using R2 to analyze the challenge file. So let's get started with behemoth5. As always, we start by connecting to the challenge server via SSH. And then have a look at the provided challenge files. Again, only the executable, so we run it. When executing behemoth5, we see no output, so we must find another way to understand what a program does. As with many challenges before, we use ltrace to see the library functions behemoth5 calls. The program starts at libc start main and then calls fopen to read the password file of behemoth6. Then perror is called, which states permission denied. Finally, the program exits with exit code 1. That's weird. Let's run ls again and have a look at the permissions of the executable. behemoth5 should be able to read the contents of the behemoth6 password file, so I'm not sure why it can't read it. Anyhow, we need to find out what the program is supposed to do. Since I always wanted to have a look at R2, I thought that now is a good time. Because we probably have to look up some man pages, I start a new tmux session and start R2 to inspect behemoth5. Then, to get things started, I use the AAA command to analyze the executable. Then, we need to find the main function. R2 is great in providing good documentation when entering a command, followed by a question mark. S here stands for seek, and we want to seek a function, so we can use sf to seek main. Now, we want to have a look at the disassembly of main. For this, we can call pdf, which stands for print disassemble function. This now doesn't look very different to what we know from GDB, but there are arrows that highlight jumps and some other details. The really cool part is R2's visual graph mode. When entering two capital V's, we get a graph in which one can clearly see branches in the code. Now this is the view that we're going to use to understand what behemoth5 does. After the function prologue, the main function starts with a call to fopen. Of course, that's a call we already saw with ltrace. If fopen returns 0, which is an error, the program calls perror and exits. That's what we already know. But what happens if the file can be read? In that case, fseek is called. The man page of fseek states that the fseek function sets the file position indicator for the stream pointed to by stream. So it is used to set up reading the file. Afterwards, ftell is called. The ftell function obtains the current value of the file position indicator for the stream pointed to by stream. Then rewind is called. The rewind function sets the file position indicator for the stream pointed to by stream to the beginning of the file. Okay, so that's a lot of file I/O setup. After that, malloc is called to allocate memory to store the contents of the file. And after that, fgets is used to finally read the file contents. Stringlen is then called, but for now we can't see where its result is used. Finally, the file stream is closed with fclose. After reading the file, getHost by name is called with localhost. If that fails, the program calls perror and exits with exit code 1. Otherwise, socket is called. Socket creates an endpoint for communication and returns a file descriptor that refers to that endpoint. The file descriptor returned by a successful call will be the lowest numbered file descriptor not currently open for the process. The socket function takes 3 parameters: domain, type, and protocol. Domain is defined in bits/socket.h, which can be found in user include. The value 2 stands for the IP protocol family. Now on to the socket type. The types are defined in bits/sockettype.h. Socket type 2 is used by behemoth5, and that's sockdgram, which are connectionless, unreliable datagrams of fixed maximum length, better known as UDP. So finally, we have to look up the protocol. The socket main page states that the protocol specifies a particular protocol to be used with the socket. Normally, only a single protocol exists to support a particular socket type within a given protocol family, in which case protocol can be specified as 0. And that's exactly what behemoth5 does here. So if the creation of the socket fails, p-error is called and the program exits. Otherwise, ASCII to integer is called with the string 1337, which seems to be a port number. This is confirmed by the call to h2ns, which is used to convert a port number from host to network byte order. Afterwards, memset is called to zero out a string, and right after that, string len is called. Finally, in that block, send2 is called to send data to another socket. If that fails, the program exits with exit code 1. Otherwise, the socket is closed and the program exits with exit code 0. Now it seems that behemoth5 opens the password file of behemoth6, then reads its contents and sends them via UDP to localhost port 1337. Maybe we can wait for a connection on that port so that we can receive the contents of the password file. To achieve this, we can use netcat. We tell netcat to wait for incoming UDP connections on localhost port 1337. If we now run behemoth5, we expect that netcat wrote the password to the console. And indeed that's what happened. We have the password for the next stage and are done with behemoth5. I hope you found this video interesting. At least I had fun trying out R2 for the first time and inspecting the assembly of some simple networking code. If you liked the video, please give it a like, and if you want to see me solving more CTF and wargame related challenges, please subscribe to my channel. If you have any questions, feedback or other challenges I should have a look at, feel free to leave a comment under the video below. Thank you and until next time.